part A, Roman 1, they are telling us we describe the characteristics of a Poisson distribution for max. Then Roman 2, we are to compute the probability of days on which 2 cars were demanded. But before we look at other parts, let's first talk about Roman 1. We are talking about characteristics of Poisson distribution. As you recall, I said Poisson distribution, Poisson distribution is as the result when n is large and the probability of an event occurring is the probability of an event occurring, that is P, is very small. Or that is the probability of success, P. Okay? P can mean the probability of an event occurring or what we call the probability of success. So that is number 1. That is number 1, okay? Then next, you can talk about the formula. So the probability of P, which is our variable X, is equal to, that is the formula you will need when you're handling Poisson distribution, okay? Then you can also say that it has similarities. It has similarities with the binomial distribution. It has similarities with binomial distribution, and it describes the number of events that occur within some given interval. Okay. Can also have that as part of your description. Okay. You can also say that it is applied where number 1, as we have said, where n is very large, and perhaps not known. You may find that in the question you cannot tell what is n. So in such scenario, you cannot use binomial distribution, you cannot use normal distribution. You will not test. Okay. Then number 2, it can also be applied where events occur, where events occur at where events occur at random, where events occur at random. That is, they are independent of each other. Okay. Then maybe the next, you can say that where you are dealing with, where it is a discrete a discrete distribution, and the mean is equal to the variance. Discrete distribution simply means the distribution that describes a variable that can take on a countable number of distinct variables. Then lastly, maybe we can say that where the probability of an event occurring, that is your P, is very small. Small meaning that relative to the probability of the event not occurring, Okay, so that's what you can write if they say you give some characteristics of, binomial distribution. You can just have that summary, and any other description. But we can stop here for now. Any question here? Okay. Remember, every time they say describe, colleagues write anything you know. That was Roman 1. Roman 2, they are telling us we compute the probability of days on which 2 cars were demanded. And they are saying an events management company has a number of wedding cars which it hires out during the week. The daily demand for a car follows a Poisson distribution with mean 3.5. So you have just that statement, and you're required to compute the probability of days on which 2 cars were demanded. Okay. So you see that here you cannot tell. Actually the number of wedding cars for this company. That is N. You don't have N. And we say that it is one of the reasons why we may need to use what? Poisson distribution. In a situation where N is unknown, you can apply, or you can use it by Poisson distribution. Here, all you need is mean, and the number of events may be occurring, what you're talking about. The probability. Now, we are talking about the probability of days on which 2 cars were demanded. So what you're going to do here, that is Roman 2. Roman 2, we need the probability of days on which 2 cars were demanded. Okay, so how can we get the probability? Probability of X is equal to you can use R, or is equal to, then you bring this. This is your formula. That is the formula. As we are trying to get the probability using Poisson distribution, this is the formula we use. Okay. So it means that here we are dealing with R, which is equal to here. If you use R, then here where you have X, put R. But let's use it. Let's maintain small x. So this is capital X, this is small x. Or if you don't want to be confused, you put here R, then where you have X here, put R. Here, put R. So our R is equal. We are given mean in the question, and mean is equal to what, colleagues? In the question, mean is equal to what?
0.5.
3.5. Okay. They can say average, they can say mean. So just you needed to know that. So substitute in your formula. Substitute in your formula. Where you have R, put 2. Where you have lambda, put 3.5. So this is power. This is power 2. Then everything we say over 2. So what do you get? Do you know how to use a calculator? Okay. So get your calculator. Click shift. Then click where you have lean. IN. There is that button where you have IN. So click shift. Colleagues, are you following what I'm saying? Click shift, then click on that button where you have IN. That is lean. You will see E appearing on your calculator. Then don't put power. When you see E appearing, immediately write negative 3.5. Okay, then times open bracket 3.5. Since here it is squared, you can click on where you have x squared. But in a situation where you have power, let's say 4, you click on power, then you put that power. Then close bracket, then everything divided by 2, write 2, then click shift. Once you click shift, you also click on that button where you see X. It's the button before constant. Are you getting the answer? Okay. Okay. Someone is saying, I repeat, please get your calculator. Click shift. Then click on that button after log where you have IN. You will see E appearing. Are you seeing E?
Yes.
Once you see that E, write negative, click on where you have minus, then write 3.5, say times open bracket, 3.5, power 2, then close bracket, divide by 2, then click on shift. Once you click on shift, click on that button before constant, where you have X factorial. You click on that, you will see a factorial appearing. Are you seeing that factorial?
Yes.
Then you cosine it. So what do you get? 0
0.185.
185. Okay. So that is your probability. Please, if you have an issue with using the calculator, it's high time you say we repeat, because we don't have another time to repeat these things. Let me hope everyone is okay. Okay, so that is Roman 2. That is Roman 2. Yes, please.
Inquiring
Mm.
if they ask, like for example, there they asked to get probability of days on which two cars were demanded. When do we get for both one probability of x is equal to 1 and probability of x is equal to 2?
That is if they have used some words like more than 2 cars or less than 2 cars.
Thank you.
Because here you see it is direct, 2 cars demanded. Okay. You
Yes.
get?
Yes.
Okay, so let's continue to the next part. Part B. They are telling us we use Bayes' theorem. Using Bayes' theorem, compute the probability that the drink selected one is not substandard. This word is very key, is not substandard. Then Roman 2, you use Bayes' theorem and compute the probability that the drink selected the drink selected and found to be substandard. So here you see there is no word not substandard. You find the probability that the drink selected and found to be substandard was produced by line Q. Okay, so let's read through our case study. So you recall I talked about this. Those who attended the physical discussion, even in the online, talked about this. But when we are using Bayes' theorem, colleagues, this is like conditional probability. It's like conditional probability. So we needed to read through our case study and summarize what we are given. They are telling us that a soft drinks factory based in Kawempe uses 3 lines K, Q, and R to produce a 45%, 30%, and 25% of its total production respectively. So it means that 45% is for K, then 30% is for Q, and 25% is for R. The percentage of substandard drinks. So here you have the percentage of substandard drinks from the 3 lines are 5%, 6%, and 9% respectively, given that a soft drink is selected at random. Okay, so this is the only information you have. This is the only information you have. And you see that in the question, you are talking about a drink selected being not substandard and being substandard. Those are 2 different things. So you need to analyze very well. So what you're going to do here, so this is part what? Part B. This is part So this is part. Part B. So part B, let's first note what we are given here. We have 3 lines here, KQ and what? KQ and R. Soft ring, okay, there's KQ and R. Okay. So here I can just say the probability of K is equal to, we are given which percentage? 45%. So I can say 0.45. Then the probability of Q is equal to what? The probability of Q, colleagues, is equal to what? 30%, 0.3. Then the last probability of R is equal to 0. What? What is the remaining percentage? 25%. 25%. Okay. Here we are given the percentages. You can convert from percentages to probabilities by just making them into a decimal points. Okay. Then we also say that let A be the event that a drink is. Let A be the event that a drink is substandard. Okay. Once you say that, it means that now we need to go back here. We need to go back here. They are saying the percentage of substandard drinks from the 3 lines. That's why this is very key. From the what? From the 3 lines. Remember, our 3 lines are K, Q, and what? And R. So the percentage of substandard drinks from the 3 lines are 5%, 6%, and 9%. What does this one mean? It means that if you need the probability of finding that a drink is substandard, given that it is from line K, is equal to what? Is equal to 5%. 5% is the same as what? 5% is the same as 0.05. Then next, the probability to find that a drink selected is substandard, given that it is from line Q, will be equal to, colleagues, you are quiet. Is equal to what? Is equal to 6%, which is the same as
0.06.
0.06. Then lastly, probability of finding that a drink is substandard, given that it is from line
R.
R is equal to
0.09.
0.09.
0.09.
Okay. Okay. So we start, this is the information that we have. This is the information that we have. So they are telling us on the required part, we compute the probability that a drink selected is not substandard. A drink selected is not substandard. So how are you going to get that? Remember, you have said A, let A to be your event that a drink selected is substandard. So we have two ways. We have two ways you can get this. You can first get the probability. You can first get the probability of the probability of substandard, the probability of substandard, the probability of substandard drink can be, that is PA. Let's say that the probability of finding that the drink selected is substandard is equal to probability of A. Okay. Once we get the probability of A, we will be in a position to get the probability of selecting a drink that is not substandard. So what will happen here is the probability of A will be equal to the probability of A will be equal to the probability. Here we have these things. If you can master this, the moment you're dealing with conditional probability, these formulas will never change. These formulas will never change. Here you have a probability, you have another statement. So it means that every time you're dealing with a conditional probability, every time you're dealing with a conditional probability, you must be having such kind of information. You must be having this first part, and you must be having another related part, which is this one. Then, the moment you realize that you have these items, these probabilities, for you, what you will do, you simply get the probability of the first K, then you multiply by this one. Okay. I can put this one in maybe the first part. I put them like this. Then I also pick this one. Then I multiply by its corresponding condition. The moment you're dealing with conditional probability, that's how you will be handling your thing. Then add, simply like this. That's how you can get the probability. Because you see, what you're listing here is based on your event, that a drink is what? Is substandard. Okay? So for me to get that probability of an event that the drink selected is substandard, I simply use this technique. Okay, then once I do this, I substitute. I have everything. What is the probability of K? 0.45. I multiply by what? 0.05 plus probability of Q is what? 0.3. Then I multiply by 0.06 plus I get what is probability of R? 0.25. Then I multiply by 0.09. So if you use your calculator very well, what do you get? You can put everything on your calculator and get one penny answer. Open bracket 0.45 times 0.05. Here you get 0.0225, then plus 0.3 times 0.6, 0.018 plus 0.25 times 0.09, which is
0.2655.
0.2.
The whole total.
Like this, eh? Okay, the whole probability is what? In total, if you add
0.2. I'm getting 0.26.
0.26,
55.
55. All of you are getting this? Okay, so that is your probability of selecting a drink that is substandard. But remember, what we need is a probability of selecting a drink that is not what? Probability of selecting
Standard.
that is not substandard. So what you will do here? So what is the probability of selecting a drink that is not?
Abel,
Yes, please.
my answer is different.
But I don't know the problem. Is using the what do
Let
you have?
someone else. Mine is 0.063 after adding those digits. Let another
But
person
the
confirm.
last probability is not 0.0225.
Which one?
That one there before the answer. That 0.0225 is not right. After
This one.
0.018.
This one is not right.
Yeah, because me just gave you the final answer.
It is right. It is right.
Then that
This
is the answer. If it's
This
right.
is wrong. Colleagues, use your, please QT. This paper people fail because of calculator. It's not because that people don't know, but how we use our calculator.
But I'm getting that total.
How? Someone with this figure? Anyone with this figure?
For me, I'm getting 0.063.
Please use your calculator very well. Even you can do this directly on your calculator. Open bracket, do everything. Open bracket 0.45
Yeah, I
times 0.
did direct and I didn't get that.
Have you tried again?
Yes. We can go on. We shall confirm that later.
Don't say we go on. Get your calculator, repeat.
I'm repeating.
Hey, colleagues, it will be absurd to just fail a paper because of not using your calculator very well. You know things, but you're using the calculator only. Take your time. The moment you see that you know something, don't rush. Make sure that you are very, very attentive. Attention to detail is very key here. But this is the right thing. This is the right probability. Okay, so the probability, what is the probability? What is the probability of selecting a drink that is not substandard? What you will do is to just say, you will just say the probability of a drink that is not substandard. You can put here power. You can put here something like this. Is equal to, you just get 1 minus the probability of A. What do you get? Which will be equal to 1 minus 0.03. And finally, what is our answer?
0.937.
0.93. 0.937. So that is your answer. That is your answer for part A. Okay. Any question? Oh, we have another method, but I don't know. But I think this one is the easiest. But another method is someone can first change here. Can first change here and say that the probability of A, the probability of selecting selecting a drink that is not substandard, then over K is equal to
0.05.
You're selecting a drink that is not substandard from line K. It will be 1 minus 0.05, which is equal to what? 0.05. 0.05.
0.95.
0.95.
Then here you do the same. Here you do the same, but you put Q, which is 1 minus 0.06. What do you get? 0.9 what? 94. Okay, then here you do the same. But here you put it from line R. Okay. Is equal to what? 1 minus 0.09. What do you get? What do you get?
0.91.
0.91. Okay, so once you have this, you don't need to do all this. For you, you will just say, okay, you will just say the probability, you just pick this. Here, you just pick this. What is the probability or that is method 2? What is the probability of this? It will be equal to, now you copy this, you copy this, but we are changing something here. We are just, where we have A, we put this. Where we have A, we put this. Where we have A, we put this. Then you substitute directly. You will get the same answer. Here it will be 0.45 times we have this as 0.95. Then add the next is 0.3 times 0.94, then plus 0.25 times 0.91. You get the same answer if you use your calculator very well. You will still get 0.937. So it's up to you. It's up to you to choose the method that is easier for you. Okay. So any question here? We are done with Roman 1, rather part B, Roman 1. Then part B, Roman 2, part B, Roman 2. Roman 2. What are we told to do? They are saying that sorry. We compute the probability that the drink selected and found to be, the drink selected and found to be substandard was produced by line Q. What does this one mean? Here they are asking you, the probability of, you recall what I said, the technique, what you have here. You see what you have here. Already you have a substandard. The drink is substandard, but selected from what? From line. Are we selecting from line Q? Which line are we selecting? Line Q. You see what we have here. That's why I like these questions, because once you list your information here, it's a matter of making opposite. Already we have this information. Substandard and is from what? From Q. Okay, so here I will make the opposite. When I am answering part Roman 2, I will make opposite. Where I have A, I put Q. Then where I have Q, I put A. Just like this. Then you say is equal to, and this the formula also will never change. You get is equal to over probability. Here it is over probability of substandard, already probability of A. What you have down. And the probability of A you already have. If you don't have probability of A, then you have to first compute like using this formula. Next time you'll find that you don't have A, you are the one, and you don't have Roman. So it will be just a matter of saying where you have A, probability of A, you just copy all this. Okay. This formula cannot change. If at all we didn't do part A, rather Roman 1, we could just, where we have probability of A, you just put that all this information. Okay. And this formula is not given. You're the one to recall. We use this formula when we are dealing with Bayes' theorem. This is the conditional probability. Okay. Okay, since we have everything, we just substitute. This will be equal to probability of Q where you have probability of Q, I put 0. What? 0. What is our probability of Q? 0.3. Then what is our probability of A given Q? Probability of A given Q was what? 0.06. Then probability of A, since we already have the probability of A, it is 0.93. We substitute. So what is the answer?
Zero 0.286.
0.286.
Okay.
Yes, please.
I thought the probability of A is 0.063.
Low battery, please charge.
Yes. Thank you. Yes. Yes. Probability of yes. Colleagues, what is probability of A? This is not A. The probability of A is actually this one. Okay. Here we are talking about the substandard. We are not talking about a drink being not substandard. Okay. So what do you get?
0.286.
How? Maybe for you had used the right thing. 0.2.
857.
Okay. So that is the answer. Okay. Colleagues, I have a request to you. Understand how we get the conditional probability. This formula. For you, if you see something like this in the question, that you get the probability that the drink selected or something selected, they start with an event, the substandard, then followed by the what? Followed by your product or your lines. You just think about this. You just make the opposite of what you had initially here. Then once you make the opposite of that, then you bring in this formula. But also another thing I needed to note to talk about here is you must make sure that you follow you follow what they have indicated. If they have said that, if at all they said that you look for the probability of the drink selected and found it to be not substandard, you know what you do now. Where you have A, you put our bar, our upstroke. Okay. Okay. So any question about this part? Roman 2, we are done with Roman 2. I wanted to talk about Bayes' theorem. I think we handled this. Do you recall?
Yes.
We discussed this also.
No.
Okay. Let's handle part B. Let's handle part B. They are saying statistical data showed that 18.6% of the male students and 18.9% of the female students who completed their degree course at Makerere University passed with second class upper in 2019. 2019, okay. If 250 male students were sampled, find the probability that more than 50 male graduates passed with second class upper degree. Okay, so we needed to note what we are given. So we are handling March 2022. It is question 2, part B. Okay. The question is saying find the probability that more than 50 male graduates passed with second class. So here you have your variable, male graduates. That's your focus. Let me see our random variable. Let X be our random variable. Random variable X, okay. And you're talking about male graduates who passed. The students who completed the degree course, okay. What you have percentage. Those who are male students, they completed the course with second class upper. Also, female students who completed the course with second class upper is 18.9%. Okay, so what do we need? We need the probability that more than 50 male graduates passed with second class upper. Male. Here you are dealing with what? Male. More than 50. Remember, you have sampled how many? You have sampled 250. So we want to see out of 250 you have sampled how many passed away. What is the probability of finding that 50 male students passed with second class upper? So what you will do is to know that you have N. You have N as what? 250, since you're dealing with male. you can know the probability of success, probability that male students passed is equal to what? The probability that male students passed is, aren't you saying that it is 18.6? 18.6%. What do you get? If you get 18.6% divided by 100, what do you get? It is 0.186. Okay. Then what is now the probability of students who completed the course but with no second class upper? That will be your Q. It will be 1 minus P, which is equal to 1 minus 0. Colleagues, are you following?
Yes.
Is equal to what? 1 minus that probability, you get 0.814. 814. So that is our Q. So the question is, you have N, you have P, you have Q, and you're looking for the what? You're looking for the probability of X is greater than what? X is greater than, remember X is our variable. Male students who passed, probability of X is greater than 50. That's what you're looking for. Now, the question is, which concept are you going to apply here to get this probability? Are you going to use binomial? Are you going to use Poisson? Are you going to use the normal distribution? Here you cannot use the in this situation. Don't use the Poisson. I said we test. We test here, get any P. Then also get what? Any Q. First do this, get any P, any times P, then also get any times Q, and see whether all are above 5. If all are above 5, then you must use normal distribution. If you find that one is below 5, or all are below 5, then you use binomial distribution. Are we together, colleagues?
Yes.
Use normal distribution. For you to use normal distribution here, you must confirm that any P and any Q all are greater than what? 5. Okay. So N is 250.
All are greater than 5.
All are greater than 5. So since
yes.
Okay, since you have computed, since NP and NQ all greater than 5, normal distribution will be applied. So since you have confirmed that all are greater than 5, then apply normal distribution. And when you are using normal distribution, you're basically standardizing. You're standardizing. you recall that as we are using normal distribution, we are standardizing X. Where we have X, you must put Z. But as you standardize X, which figure are you standardizing? You're standardizing 50. But as you standardize 50, we follow the formula. Z is equal to what? Do you have mean?
Yes.
What is your mean? What is your mean?
$46.5.
Mean is equal to N times what?
P.
Which is 250 times 0.183,
186.
which is equal to
46.5.
46.5. Okay. Then what is your standard deviation? Standard deviation will be
We
equal
don't
to
have NPQ.
standard deviation is equal to root 2 NPQ. NPQ stands for variance, but we take square root of variance to get standard deviation. If you are looking for variance, variance is equal to NPQ. N times P times Q. But here we are interested in what? We are interested in standard deviation. So you are going to take square root of, since I get 46.5 times what is Q?
0.81.
What do you get? What do you get?
5.5208.
You have 5 or 6. And
6.152.
is 6.152. Okay. Use your calculator very well. Since we have everything now, we can standardize this. So this probability. Now, colleagues, you see that you're dealing with a figure where 50 is not what? 50 is not inclusive. Probability of X is greater than 50. 50 is not inclusive. If you want to put this, to make this one, this to deal with inclusive figure, you can say probability of, because we know that for you to get the number that is greater than 50, you start from 51 and above. So it can be, this one can be the same as, this one can be the same as probability of X is greater or equal to, probability of X is greater or equal to what? Is greater or equal to 51. Do you agree that this one is equal to the same as this? Colleagues, do you agree that this one is the same as this? Now you are quiet. Here you are looking for values of X that are greater than 50. The number of male students that are greater than 50. So it means that it is from 51 to maybe to your sample. Okay. So if you want to deal with inclusive figure, then you should rely on this. If you want to deal with exclusive figure, you should deal with this. So which one you want to deal with? What, inclusive figure or exclusive figure? Because all of you can be marked right. This one is the same as this. So we deal with what? Remember, if you're dealing with if you're dealing with the inclusive figure, we either add the 0.5 or subtract 0.5 on our what? On our value of x. And if the sign is greater, you get the figure, you get like, now like this one, the sign is greater. So if the sign is greater, you subtract, okay, 0.5. And if the sign is less, you add the 0.5. That is if you're dealing with inclusive figures. We are trying to standardize now. We are trying to standardize. So we say that this one will be equal to probability of z, where you have x put z is greater or equal to since you're standardizing, it will not be 51. Where you have 51, we are standardizing by bringing in this. So you have to say is greater. Here I will say, okay, we are dealing with inclusive. It is 51 and the sign is greater. So we do what? We get that 51. We get that 51 minus 0.5, which is 50.5 minus mean colleagues, please, if something is not clear, you let me know, I repeat. I want you to understand this thing, eh? Over standard deviation 1.15. The reason why we are changing from 51 to 50.5 is that we are dealing with inclusive figure. 51 is inclusive. And if you are dealing with inclusive figure, then subtract 0.5. If the sign was less than, if I told the sign was less than or equal to, then you get that figure plus 0.5. So if you're dealing with exclusive figure, probability of, you're dealing with exclusive figure, that is probability of x is greater than 50. This will be equal to, now you just say probability of z is greater. Now you bring this, but you don't subtract or add anything. You just bring 50 the way it is. So you understand the difference. You understand the difference. So now someone may be wondering, if I use this, will I get the same answer like someone who have used this? The answer may a bit be different slightly, but you will be marked correctly. Just all you need to know is that for you to add 0.5 or subtract 0.5, you must be dealing with inclusive figures. You must be dealing with inclusive figure. So it means that for you to add 0.5 or to subtract 0.5, you need to state in an exam, you need to convert from this to this, and you work with this one. But someone who didn't convert from this to this, then he or she can deal with what? Exclusive. He can deal with. Okay. So once you have this, let me continue with the inclusive figure. So once you have this, what do you get? If you get 50.5 minus this, what do you get? Probability of Z is greater or equal to. What do you get, colleagues? Is greater or equal to what? If you get 0.5 minus 4.6 over 6.15, to what do you get? Put some speed, please. Put some speed. Do you have 0.65?
0.6502.
I said, you recall what I said? Don't give yourself a burden because you want to read the value from the table. Burden, maintain 2 decimal points here. Greater or equal to 0.65. So all you need is from 0.65 to infinity. Okay. Here all you need is. So finally, your probability of Z is greater or equal to 0.6 will be equal to, you know that from here up to infinity is 0.5. So you get 0.5 from this separate line up to infinity is 0.5. So you don't need from here up to here. As we read the value from the table, we normally read from this to where you have the value. So we are going to say minus probability of 0 less Z less 0.65. So this will be equal to 0.5 minus, we go to our table. Colleagues, are you on?
Yes.
We go to our Z table, and see our Z table. That is the first one, normal distribution. We need 0.6. This is your Z, where you have 0.6 is here. Then the next figure after 0.6 is what?
5.
So you move horizontally, look for column 5. Column 5 is here. The meeting point is what? 2, 4, 2, 2. 2, 4, 2, 2. So that is your probability. The probability will be 0.2422. This is from Z table. Finally, your probability will be what? If you get
0.2578.
so the probability is 0.2578, and that is your answer. That's all about this part. And if there is no question, we stop here. We are going to add more things next time. Let me
Thank
hope
you.
you have picked something.
Yes.